small mistake. Faith? Were you out yesterday? Oh, okay. All right, a lot of these trig identities you did last year, we're going to use them to sort of simplify things, and then also there's a whole section of solving trig equations that you never learned last year, and that's what we'll pick up on when we get back from February break, but you need to know these identities and how to use them. So we're just going to review. Obviously there's sine, cosine, and tangent, which are what they are. Sometimes tangent, though, can be perceived as sine over cosine. I think you knew that, right? Does everyone know that tangent is sine divided by cosine? Okay. Cosecant, these are your reciprocal functions, which, depending on who you did last year, who you had last year, I don't know the depth that everybody went into this because it's kind of one of those topics where we're not sure in Algebra 2. But cosecant is the reciprocal of sine. So cosecant can be replaced with 1 over sine. Secant can be replaced with 1 over cosine. And cotangent can be replaced with 1 over tangent. Or 1 over something is just like the reciprocal of it. Are you familiar with that? Okay, so if I also, another way of taking the reciprocal of tangent is then rather than doing the sine over cosine, cotangent can be cosine over sine. So those are your reciprocal identities, and you'll see us use those today. Your Pythagorean identities, you only did one of these last year. You did sine squared of theta plus cosine squared of theta equals, do you remember? 1. Nice. Okay, I think, at least if you had me, that's the only one we did. The 2 others. Okay, so there's 2 others, and I don't ever remember offhand the 2 others, but I know how to get them. If you divide everything by sine squared, you'll get another one. So what is this divided by sine squared? 1. What's cosine squared divided by sine squared? Nope. Cosine divided by sine, but you're on the right track. Cotangent. And what is 1 divided by sine squared? 1 over sine is cosecant squared. So that's the second one. And the third one is still taking that original, and rather than dividing everything by sine squared, dividing instead everything by cosine squared. So what is sine squared divided by cosine squared? Tangent squared. What is cosine squared divided by cosine squared? 1. And then 1 divided by cosine squared is secant squared. I'm going to give you those. You don't have to memorize those. But what you do have to be able to do is understand how they can be rearranged. So if you ever see a sine squared plus a cosine squared, let's just start with that one. You can take it out and put a 1 in instead. That's the way this is arranged. You can take a sine squared, cosine squared out and replace it with a 1. If you see a sine squared somewhere, like if you have a problem, let's go down to number 2 right away. If you have a 1 minus sine squared, 1 minus sine squared isn't directly from our list, but we can easily add and subtract things over. So like I could subtract over a sine squared from both sides, and if I did that, subtract sine squared and subtract sine squared, cosine squared theta equals 1 minus sine squared theta. So I just rearranged that. So now when I see a 1 minus sine squared, I can take it out and replace it with cosine squared. So I will give you the original 3. You have to be familiar with how they can be rearranged when necessary to do a convenient substitution. Does that make sense? Okay? There's a gazillion ways you can rearrange any of these, so I'm not going to show you all that. You just have to be ready and willing to flip things around in there to be able to do a substitution. Okay? double angle formulas. We will also, I'll give you those. And essentially, if you see the sign of 2a, you can replace it with that, or vice versa. If you see 2 sine a cosine a, you can go backwards. So we'll see a little bit about how to actually operate those when they come up. So, in short, if I were to give you, I'm just going to write this here, sine of 2a equals 2 sine a cosine a. If I were to ask you to find if you saw this, 2 sine of 15 times the cosine of 15, without a calculator, you would have no idea what to do with that, as far as like an exact value is concerned. Because you don't know the sine of 15. You only know sines, cosines, and tangents of 0, 30, 45, 60s, and 90. So 15 would throw you off. But if a is 15 and we translate this formula backwards to the sine of 2 times what our a value is, a was 15. So it becomes the same as the sine of 30, and it will just be 1/2. Yeah, you're going to have those. So we'll just... It could go either way. It's a little bit tougher with this one to go, like if I gave you the sine of 60, you could change that to the sine of 2 times 30, and then your a would be 30, but you already know what the sine of 60 is, so when you take half of things, it doesn't really, it still plays into values that you know, so it's a little bit tougher to use it that way. But you'll see those come up, and I'll give you those, and then once they come up, I'll show you how to use them. So, in general, simplifying, and this is, I don't know how much of this you did last year, but when you're simplifying things, I think the first technique is to get everything in terms of sines and cosines. If you can get everything in terms of sines and cosines, a lot is going to cancel. So when I see a secant, I'm going to change it to 1 over cosine. This is secant times cotangent. So there's my multiplication symbol. And cotangent is what in terms of sines and cosines? Cosine over sine. And so once you have things, a lot of times in terms of just sines and cosines, you'll see cancellations. That'll reduce to 1 over sine. And the most concise way to write 1 over sine, cosecant. Does anybody have a little trick as to how they remember what's the reciprocal of what up here? Well, I mean, there's no absolute way, but I just attribute it to the letters are flipped. Like the cosecant C gets paired with the sine S, and the secant S gets paired with the cosine C. Because those are the two tougher ones that get confusing. Cotangent being 1 over tangent, that's not bad, because they both have the word tangent in them, so they go together. So, raise your hand if you did not do this last year. Okay, so everybody did it. Raise your hand if you don't remember doing stuff like this. Did anyone not do stuff like this? Okay, that's good. You think you what? Yeah, just a day. Because it probably, like, the reason I don't think it would ever be on your Algebra 2 Regents, so I wasn't going to spend a week on it. But otherwise, we just tell you what these are and you never use them, and then these do come up. And so just to help kind of reinforce it, I do a day of this. But anyway, number 2. Secant is 1 over cosine. And then 1 minus sine squared. This is kind of what we already talked about. Some of you may be able to visualize what 1 minus sine squared will equal once you subtract that over. And if you can do that, fine. You don't have to show your work. But when I subtract sine squared from both sides, it will say cosine squared equals 1 minus sine squared. So I'm going to take this and replace it with cosine squared. Good? Which is technically over 1. And then if it was an x and an x squared, it's no different than it being a cosine and a cosine squared. This one cancels completely. Agreed? And the squared goes down to a first power, so it's just no longer there, and that whole thing just becomes cosine. Good? Okay, number 3. What are we going to do with cosecant, if anything? 1 over sine times, what are we going to do with sine, if anything? Keep it. Minus, now you could change sine squared. Anytime you see squared things, you should be suspicious of the ability to use a Pythagorean identity. But if you can already foresee what is going to happen with this first piece, it's going to become 1. It'll just be 1 minus sine squared, so it's worth keeping that sine squared, because if you rearrange this first one, 1 minus sine squared will equal cosine squared. Good? Okay? Number 4 is going to use a double angle. So you've got the 2 sine squared. We're going to keep that put for now. Changing it to a 1 minus cosine squared eventually is an option, a rearrangement of that, but I wouldn't jump to that right away before you've expired your other options. The bottom is a double angle. So if you go up to your sine of 2a, we can take out the sine of 2a and replace it with 2 sine a cosine a on the bottom and leave the top the same. And we're just ready to start canceling. So what cancels? The sine from the bottom with one of the 2 sines on the top, right? The squared would just be gone. How about the 2's are gone? No, because it's the sine of a. So you can't just have, you can't let the a's cancel and have it be like sine of nothing over cosine of nothing. So it's just sine of a over cosine of a, and sine over cosine is tangent, right? Sine over cosine, so this whole thing just becomes the tangent of a. No, so you'll just get used to looking for, like, if you see, like, sine, cosine, or tangent of 2a, you'll just get used to using it. One thing I should point out is that the cosine of 2a has 3 options. And so when the cosine of 2a comes up, we'll have to talk about the strategy of deciding which one to pick, and it might be a little bit of trial and error. Nothing is wrong. I could easily, what is going on out there? No, I feel like there's a teacher out there with me. Although maybe we should check it. In any of these cases, you see how all the double angles of cosines involve a cosine squared or a sine squared? It's actually within a class. So on this one, like if I were to take the cosine square and replace it, go up to your Pythagorean identities in the upper right corner. What can I replace that cosine square with? 1 minus sine squared. So if I did that, 1 minus sine squared of a minus sine squared of a, it just becomes 1 minus 2 sine squared of a. Do that. So they're all intertwined. And then if I wanted to get rid of the sine squared of a, or whatever place it was, 1 minus cosine squared of a. And but there's a negative out in front, and that would have to be distributed. So it would be cosine squared minus 1 plus another cosine squared, which is equal to 2 cosine squared times 1/3. So really, they're all the top one. It's just this one is like substituting out the sine squared, and this one is like substituting out the cosine squared. But they're all intertwined. So if you do pick the wrong one, it can still all, yeah, it will if you stick with it. but we'll talk about strategies of which one to pick when I get there. Number 5. What do we replace cosecant with? 1 over sine. And then the sine of 2x. Just take the double angle for sine. There's only one option. That first one, sine of 2a. Except for now we're just dealing with x. So the sine of 2x is 2 sine x cosine x. And if you'd like, you can put that over 1 just so it's fraction times a fraction. And then the denominator sign can cancel with the numerator sign. And you're just left with 2 cosine x. Okay. So here's a cosine double angle in 6 that we're going to have to choose from. And it is, even for me, it's hard to like fully foresee what's going to happen, so without a little trial and error, but my first thought when I see this is there's a minus cosine squared a after this. So if I do pick the first one, which includes a cosine squared and a sine squared, if I take this cosine squared, the first version, this minus cosine squared after that will cancel with that one. Yeah, that's what I would do. So I would take this, replace it with cosine squared of a minus sine squared of a. And then there's still the minus cosine squared of a after the fact. And then just combining like terms causes those two to cancel, and it's just minus sine squared of a. Just pretend for a second that I picked a different one. It doesn't matter what it is. Let's pretend I picked the second one, 2 cosine squared of a minus 1. If I picked that one, it would be 2 cosine squared of a minus 1 minus the cosine squared of a. I can still combine like terms. What's 2 cosine squared minus 1 cosine squared? 1 cosine squared of a minus 1. And you don't even need that 1. And then cosine squared of a minus 1, think about rearranging. If I wanted cosine squared of theta minus 1, I'd have to subtract this 1 over to get it all on the left, and I'd have to subtract the sine squared over to the right, so it would be negative sine squared also. You see that? So it still all works out. It's not really critical, although some are easier than others, because you don't have to see that Pythagorean identity if you pick this one. Okie doke? Any questions? Okay. When you add and subtract, it gets a little bit tougher because adding and subtracting fractions requires a common denominator. And how you get those common denominators is obviously important. What does this denominator need that the other one has? Sine theta, right? So in order to give this denominator a sine theta, you have to multiply by sine theta over itself. Because you're multiplying by 1, but in such a way that it will change the appearance without changing the value. So what does my numerator become? Sine times sine is not 2 sine. Sine squared. And my denominator is just sine cosine. What does this denominator need that the other one already had? Cosine. So what does this numerator become? Cosine squared over sine cosine. So now we can agree there's a common denominator. And when there's a common denominator, you can now add the fractions and add the numerators. Yes? And keep it over that common denominator. So my numerator will combine to sine squared theta plus cosine squared theta over sine cosine. Whatever the common denominator is still remains your denominator. And then what happens with the numerator? It becomes 1. Sine squared plus cosine squared is 1. So 1 over sine theta cosine theta. Now, I would say I would probably stop there, but there is the potential you could go one of two ways with this. You could treat your 1 over sine as a cosecant. So it could become cosecant theta over cosine theta. Or instead you could treat your 1 over cosine as a secant theta and keep the sine in the denominator. I would say, just so we're all on the same page, keep everything in sines and cosines. Unless it's 1 over sine, and that's it, so it can be more concisely written as cosecant, keep it that way, because then otherwise we can diverge in a different direction. This is still a single fraction, so you're good. Okay, on 8, what's that? It's going to probably like simplified, and so you see a sine square. Honestly, it would be best as a multiple choice because you're right, there are multiple ways of writing it. This is technically a single fraction. You wouldn't be wrong. So's this, so's this, so's that. So I would probably attempt for multiple choices and then just make sure you can kind of figure your way to one of these. Number 8 is still two terms. We want to combine it and write it as a single fraction. So we still need a common denominator. What is the denominator currently on the first term? 1. Anytime you don't see a denominator, put it over 1. So what does this one need that the other one has? Sine. What does this one need that the other one has? Nothing. You could give it a 1 if you wanted to, but that doesn't really do anything. So you have sine theta over sine theta minus cosine theta over sine theta. You have a common denominator, so now you're ready to condense this into a single fraction. Sine theta minus cosine theta all over sine theta. This one, there's not really an option to go any further. That's not a single fraction. Just write as a single fraction. That would be an equivalent expression. You just have to follow. Okay, and then the last, this one down here, simplify in terms of sine and cosine, which is kind of what we're doing. We just have to simplify. What is not simplified about this? A fraction within a fraction, right? So it's complex to begin with. And you have two fractions being added together in the denominator. So you want to add these first into a single fraction. Because if you have a fraction divided by a single fraction, then you can keep change flip. So we need a common denominator. And did we already do this problem? No, we didn't. No, we didn't. What does this denominator need? Cosine. What does this one need? Sine. So now those can be added together. The numerator will be cosine plus sine over the common denominator, sine cosine. And the numerator, the large numerator, was already a single fraction. When you're writing fractions within fractions, make that like main divisor, very obviously, just to help yourself, like so it's not playing a game with your eyes. So my single fraction on top stayed the same. My two fractions on the bottom got added into one fraction. So far, so good? We'll keep change flip. We'll cancel the bases too, right? Fractions divided by fractions. You keep. You change the division to multiplication, and you flip the denominator one. So the sine theta, cosine theta goes up top, and the cosine theta plus sine theta goes on the bottom. And so those will cancel, and then we're pretty much done. What's your first gut instinct on 10 when you look at it? Change what? Top. You see the Pythagorean identity in the top? Secant squared theta minus 1 is a rearranged version of this. Secant squared theta minus 1. If I subtract this 1 over, what will it equal? Tan squared. So that top can just become tan squared over tan squared 1. Okay. On your homework, just figure out. Do the opposite.